These two drones were entirely designed and built in these rather modest facilities. As you can see, we are not at the facilities of the Turkish drone manufacturer Akinci Bayraktar, but we are right here in Ouagadougou, in a neighborhood whose name we will keep secret for security reasons. Here, two young Burkina innovators, Alexandra Ouandougou and Toussaint Kientigba, both passionate about technology, are developing fixed-wing drones, drone helicopters, a rocket, and other advanced technologies.
Welcome again to another episode of WSXM channel. My name is Stefan. For those of you who visited for the first time, thanks for watching. Thanks for stopping by. So, I was watching this video from the United States of Africa channel, and this was about a gentleman who built a drone from the ground up, from in Burkina Faso, homegrown, built a drone by himself, and this is a very good video. So I say, you know what, I'm gonna just show it on my channel. Well, go and show some love to the United States of Africa channel. Tell them I sent you. Anyway, let's listen to let's take a listen to this video, and then we're gonna talk about it a little bit. Boom.
Here we have a fixed-wing drone that is also capable of vertical takeoff. And this drone, we named it Ningjin Ifrit, a local name for the designation. And for the drone that is here currently, which we designed from the body all the way to the components visible, we designed them right here on site. But now, the components here that we bought, it is just the motors, a little bit of electronics. We bought the components. But here we bought the electronic components to design in our own way. But everything from the code to the drone, the mechanical support systems, etc., we designed them on site, including the geometry, all of that. For a drone to fly, you have to calculate the wing geometry and study the aerodynamic systems, etc. All of that, we did it right here. This drone, first of all, we designed it as you see here. It will be equipped with a camera. It will be equipped with a camera that will be used for mapping, that will be used for aerial surveillance. It can also be used for detection. Since the camera will have artificial intelligence integrated into the camera, which will allow detection. For example, if Sonobel uses it to monitor its high tension lines, we can take photos, captures to train the model and tell the system that when you see this, it means this is this, it means that is that. So here's a little bit of what this drone will be used to do. Before assembly, this is where the frames and other drone components are manufactured. The printer is capable of handling many different filaments. With this printer, first of all, we do the caddy design on the computer. And after the design, now we load the file onto the 3D printer. And after loading the file onto the 3D printer, now we start the printing, and here's the result we can get. This is it. So this is a part of our drone that we're going to assemble right away. But before printing, the work is done on paper, then on the computer. We have paper on which we will study the system, do the various geometric calculations, aerodynamic ones, even often do the electronic connections, all of that. And now we move to the computer. And on the computer, we do the simulation on the computer and the parts to design. We adapt them with the design we made on paper. In terms of usage, the Ning Nifri drone, which means the eye from above, can be used for civilian purposes in the fields of topography, mapping, agriculture, photography, aerial videography, infrastructure inspection, and power line monitoring. In the security field, it can be used for monitoring sensitive areas and espionage. According to its designers, the drone can fly at a speed of 60 to 70 kilometers per hour. This success comes after many experiments combined with passion and perseverance. It has to be said that it is with passion. When there is passion, we can go a long way. Before reaching this stage, it must be said that there were many trials and many failures too. We had to do a first trial that was not successful. The drone crashed, totally broken. So we had to come back and start everything from scratch again. And today we see that there is some stability coming. So from the beginning, it has not been easy. Beyond this drone, our enthusiasts have also designed the Kuka 88 for aerial reconnaissance. The drone you see here is the Kuka 88. This drone was designed for aerial surveillance and also reconnaissance missions, terrain inspections, all of that, just like the other drone. But here, the difference with this one is that with this drone, we cannot do vertical flight. So we absolutely have to give the drone a boost by either hand launching it or catapulting it. After experiencing a first attempt where the test flight drone crashed, the two engineers chose to launch the drone from this ramp. The drone flight can be programmed. We can also do a pre-programmed flight. There, we program the flight, the different GPS positions we want the drone to go to, the different missions we want the drone to perform. We can also program the positions where the drone will go. And regarding the camera, the video feed that is handled by the operator, we program all of this so that everything will be loaded by the system. And now all we have to do is launch the drone. Once the drone is launched, that is all. The drone will carry out the mission and return to land safely. Another build that captivates is the Paiga drone, named in tribute to Captain Piga, a fearless warrior who fell for the homeland. Here is the drone we have on the table, the Paiga. That is its three-dimensional model. And using this three-dimensional model, we had initiated the purchase of this frame from a company that does carbon fiber cutting. But once we are equipped with a computer numerical control cutting machine for carbon fiber, we will be able to make all these cuts ourselves. This drone is designed solely to detect improvised explosive devices to help the defense and security forces in their resupply missions and in their advance on the battlefield. Indeed, the drone was built to detect mines buried in the ground. There is this sensor, which is a metal detector. During its mission, the drone is supposed to tilt this detector downward toward the ground, which will allow it to thoroughly scan the soil to detect mines. Since mines have there is inevitably the use of metal components such as metal wires, even tiny leads, the electrical cables that supply these mines with energy. So this detector is capable of finding them. The device features a flight control board, a flight controller, a 6-cell battery, motor controllers, 4 motors, propellers, a receiver, a telemetry system, and a sensor, among other components. For example, if our soldiers want to carry out a mission as soon as the next day, they can wake up at dawn or, the night before, send the drone to inspect the terrain first. And then, during the inspections, the drone will detect the various suspicious areas and then record their positions on the digital platform. And through this platform, our defense and security forces will be able to see exactly where there is danger. With that, the next day, during the mission, while the security forces take their route, they will take these positions into account. Once they arrive at these positions, they can try to choose manual options or specific options based on their capabilities so they can defuse these mines or destroy them before moving forward. In this makeshift workshop, our 2 young Burkinabe go beyond drones to explore the field of space with this. With cutting-edge technologies, including the design of rockets for research and experimentation. My goal here is to be able to master this field, starting from from A to Z, to utilize this entire field. We designed our own electronic board, to be able to build the drone. We also plan to design our own engines. Even though it is done through a chemical process, we are going to do it. We will design our own engine to be able to propel it. And at this level, we will have air brakes that will allow us to guide the rocket through by braking the air. Among Europeans, it can also be called air brake in the field, but it will allow us to control the effect. It is like valves. So it will allow us to guide the air in order to properly stabilize the rocket around its flight. In the military field, this rocket can be designed differently to carry military payloads. And at this level, Alexander Wandau and all his Kintigas have already planned everything. When we opt for military use, the complexity will be quite different. Since the chassis, the fuselage, we can change it, perhaps make it in carbon fiber. That is what we are planning even for our next rocket, in carbon fiber. And the electronics, we will design it in a way adapted for this military use. And at the engine level, we will need to develop a powerful enough engine that will allow us to propel it to sufficient distances for this military use. And beyond that also, we will have to develop it in such a way that it can be adapted to military drones that carry rockets. And also at the electronic cone level too, we can design it and adapt it in a way for surface-to-air launch or also air-to-surface launch. Another technology under development is LoRaWAN, a long-range technology that broadcasts waves and is intended for connected objects. So here you see, for example, these water meters. These are smart meters. So we do not need to travel to perform operations on these meters. And these meters work with LoRaWAN technology, which is typically intended for connected objects. For example, this one here is a sensor. It is a GPS. With this one, when you charge it, it runs for 2 to 3 months. You can place it somewhere in a vehicle and it activates every 2 minutes. Every 2 minutes, it sends your position data. So to view this data, we have developed a platform where you can visualize all this information Also for the meters, we have developed a remote control platform for these meters. There you go. And alongside that, a door detector. This one is a sensor, a humidity sensor that you place in the soil, which transmits regularly. Send you soil moisture data. This new technology is designed for the National Water Company to manage its meters remotely. For meter reading the index, we do not need to travel to go see the meter index remotely anymore. We already know the index sends every day. So here at the alert level, once there is a leak on the platform here already, we are alerted that there are leaks. If the meter battery, there is an issue, we are alerted. For example, the battery life of these meters, it is 15 years. In addition, the LoRaWAN technology is associated with a GPS capable of tracking the movements of people in the city of Ouagadougou. Alexandra Nwam-Daogo and Toussaint Kintiga work within the company Vixby Eco Technologies of Burkina Faso. Adams Runiel Wedraogo, based abroad. Let us say that we are not just two people. We work with engineers but who are not on site in Burkina Faso. We work with 3 engineers who are on the other side, in Europe. It is with them in synergy together that we are developing this. Yes, in Ouagadougou, here we have no partners, nobody gives a helping hand. It is just the 2 of us developing this. This work responds to the vision of the head of state, Captain Ibrahim Traoré, who calls with all his wishes for Burkinabe youth to engage fully in work, particularly in invention, so that ultimately the country can limit its imports. For these 2 technology geniuses, the wish is clear. Support from the authorities will be a real boost for large-scale assembly, whether of drones, rockets, or other technology.
So, what does this video proves, which we all know, that Africa have great talents, but because of some of our leaders who are puppets, they will take these inventions or these projects from these young people and give it away to the West, or take it and shelf it and then don't pay them. Or sometimes they even take the lives of these engineers. I have videos on my channel about engineers in Africa who lost their lives after they invent something, and then 2-3 months later you see a Western country now showing the same product, but they just modified it a little bit. Anyway, so do you see all these different kind of drones that they are using? So this is going to be good for the government to use and for also the citizens, but preferably for the government because when they need these kind of technology in their army to boost their strength. Burkina Faso is just, actually they do order drones from Egypt. They get drones from, but imagine if you can design and make your own, like what these gentlemen are doing. The possibility is limitless. And if I'm sure they did promise, whoever engineer or develop anything in the country that is useful, the government will fund it 100%. I'm sure is not somebody who talks or tells tales or stories. He say what he's doing and he do what he says. So if he say he will fund any developer, any engineer project, that's what's gonna happen, and then he will put it to use for the country's development. So I love this. And like I said, this video was taken from the United States of Africa channel. Go show them some love. Thanks for watching. Thanks for listening. Boom.